Okay, welcome. Looks like everybody's come in. We'll get started in just a second. Up on the screen, a couple of reminders. Uh, there should be a chat button over there, so you can, use that. Let's just test the audio here. How are we sounding? Are we okay? Again, you might have to adjust on your end, your volume on your device, just to make sure. But if you could tell me if you could hear me, okay. Some people could type in the chat. Yeah, is everything good? Yeah. So again, you might want to control your volume. Otherwise, you might get a lot of echo if I go too loud on my side. So just try to control the volume on your end would probably be good. Perfect. And again, we'll just get started in just a couple of minutes here. Just give everybody a chance to get in. Looks like most everybody's here, I think. Again, on the screen are just some reminders of some of the things here. We are all these live lectures and any lab sessions that we do, they are being recorded. So obviously, again, if you put your video on, you will be part of that recording. If you use your mic, you will also be part of that recording. Just to remind you of that. Probably the best thing to do is to take care of questions through the chat. I can see it, I can respond to you, so you can chat to everybody. You also can privately chat to me as well. And we're going to talk about everything in terms of the class and the exam and everything in just a minute. So we'll get to all those questions, hopefully, that you have. A couple of reminders that these will be posted online. So my thought is, and again, if you're just coming in, we're going to keep your microphones muted, and then also if you could keep your video feeds also off. Again, it just creates a lot of boxes on my screen, and again, I lose sort of a lot of my actual screen. So these will be occurring live. So my thought process here is we will continue to lecture at our normal time, which is 10:30 on Monday and Wednesdays. And you should hopefully come in live to watch those lectures. Again, that would be my recommendation because you can see the lectures live. And if you have questions, you can obviously ask your questions and we'll get on. We can get those answered for you. Again, I do know there's a lot going on. So if for some reason you can't make it to the live feed, all these, again, will be recorded. I anticipate they will be uploaded to our Canvas site with either the video or a link to the video, probably to a YouTube video. Maybe it will be embedded as well, that you could watch these live lectures again. If you were here even live, you could watch them again if you missed something or want to catch up on something, or maybe just review a section, you could do that as well. So because all this is online, we're all sharing with each other and chatting. Please remember to be respectful in anything that you should type or say or anything like that, because again, it is being recorded. Obviously, all these videos and audio files, if they are posted up online, are you for your own use, your personal use for this class. Please don't go around posting them all over the place and all that good stuff. Not that I think they would want to listen to me all over the place, but you never know. So in terms of questions, like I said, probably the best way to do it would be to type in the chat box. I will see the chat and I will see it. And again, you can do it one of two ways. You could send your chat to everybody that is there, and that would go to everyone, or you could privately as well. And again, I'll do my best. Got a lot of things going on my screen, but I'll try to see if it says private and just type you back an answer as well. There's also, I think, in the participants area somewhere you can raise your hand virtually if you wanted to use your mic or something like that. But usually in most cases, by typing in the chat box, I probably could figure out what you're asking, and we can, take care of your question and everything like that. Okay, so again, these will be posted online. It does take a little bit of time to process these videos and stuff like that. So if you're looking for them sort of instant, it will take a little bit of time to do that. And so my hope is to get those videos up online, hopefully by the next day or so, or at least the link to it, so you could, if you want to, sort of review it. So let's talk a little bit about the class and some of the things that are happening. So hopefully you had a good spring break, and we were together before spring break, and now the class has turned 100% online. So that includes both the lecture part and also the lab part. So we'll start with the lecture part first. So the lecture part, again, as I mentioned, my thought process is we will continue to have lectures at 10:30, as that seems to be the time when everybody would be normally be available. And again, we'll do it on Monday and Wednesdays. Just like you found the link for this one, you can find it in 2 different places. I will put a separate invitation link like I did in the module section, or it should also be scheduled through the Confer Zoom section of our Canvas page. So what I'm going to do is I'm going to switch over to our Canvas page just to kind of move everybody through where everything is located. So you hopefully should be able to see the Canvas page. So here, this is in the module section. If we go to the module section there, and what we'll see is a couple of important things that have sort of been added in there. And I think it also pops up on your front page. Again, this right here is the module to listen live to those lectures and labs. So the lecture part will again start at 10:30. We will open up a separate lab meeting at our normal time of 12. And the reason I'm going to do that is, again, that will make the recordings pretty much separate. So the lecture recording will be one, and the lab recording, if it needs to be posted, will be separate as well. So you don't have to go through the whole lecture to get to the lab part. So they'll be kind of separate from each other. So today we are going to open up a lab meeting. Again, if you have questions about lab or something like that. So what you'll have to do is, once we're done with our lecture part today, you'll need to come back however you did it, either through here or again through the Confer Zoom part. They both should provide links to that second meeting, which would be our lab meeting that will start at 12 o'clock as well. So once we're done with lecture, you'll have to do the same process you just did to get in here now for the lab one, and that will open up the lab one. So a lot of the labs, we'll get into that in just a second, but we'll have 2 separate ones. This is also the assignments for where you can find the lab videos and sort of homework for the lab. And our normal stuff is still up here. So everything for exam 1, exam was already gone, exam 2, and so forth, all the review stuff like normal. In addition, here's where we're at in terms of our current lectures. So we're on to exam 3 lectures. So just like normal, you can find all these PowerPoints there. So if you want to print them out or use them on your computer, or however you want to do it while you're listening to the live lecture, or if you happen to be listening to the recording, they're still available for you just like they were from the beginning. So coming back to the lab part, so there's some questions about the lab. In terms of the lab, for the most part, what we are doing is still a good question that was just asked was, are we still doing pre-lab quizzes? We are. So in terms of both the Cengage material that we used from the beginning of this semester, the homework, kind of the textbook homework, the AL2, and the pre-lab, the lab skills that's also done on Cengage, those both are still up and running. You still have to complete those assignments. So you still have to do the online homework. They're still set the same way. The online homework for the textbook will be due on the day that we take that exam, or in that area, a day or so after, or somewhere in that ballpark. The pre-lab assignments will still be due like they were before we get to the day of the lab. So on the day of the lab, the pre-lab assignment is still due. So technically today, you should have done the pre-lab assignment for today's experiment, which is experiment 14. If you did not do that today, I'm going to extend today's pre-lab assignment till Wednesday, because this is all new. We're all starting fresh here. But starting on Wednesday, if there was an experiment, which I don't think there was, because that's normally when our exam was going to be scheduled, but on every day where we normally have an a lab schedule just like normal. You got to go on there and do the pre-lab. They'll be due like they were at the beginning, which I think was about noon, 12 o'clock on the day of the experiment. So you're still expected to do the pre-lab and obviously still expected to do the AL online homework. Any questions on that part? Now, in terms of the labs, as I was saying, what they have done or going to do, and they're in the process of doing, is they're going to make some videos, I think, and some will be PowerPoint/video type presentations. I posted up already here the first one, which is today's experiment, which is experiment 14. If you click on experiment 14 there in the module section, it will take you to a page, hopefully. And when you do that, give it a sec to load here. There you go. So what you'll see here is a little description of what's in here. So this is experiment 14, some instructions on what you need to do. The videos, for the most part, I think will be just like this. They're embedded inside here, so you can actually click on it and watch the video right here. Or if you want, here's the actual YouTube link where you could cut and paste, obviously, and watch it through YouTube. So you can actually watch the video here through Canvas as it's embedded, or you could cut and paste it and watch it, either in your browser or on YouTube and watch the video. What you're going to essentially be doing after you watch these videos is just like you were in class. You're going to use the video to write down things like your observations, any type of data, if there's data, so like numbers, like the mass of the crucible was 32.5 grams. You're going to fill in your data sheets from your experiment just like normal. So let me see here, pop that up maybe. Let me switch this over just to make sure everybody can see it here. Let's go to that one there. Okay, so this is experiment 14, like you could find online or in your lab manual. And again, just like normal, we're going to basically do the experiment. And just like, for example, today's experiment, you're going to have a data table where you need to, obviously, while you're watching the video, record just like you normally would any evidence of reactions, what you see, colors, that type of stuff. For this particular experiment, they will also have a reaction table. So for today's experiment, what they'll have you do is after you observe all those reactions in the video, you're going to have to write the balanced equation for all of them here. So you want to write the balanced equation for here. This particular lab today, experiment 14, as you can see here, does not have any pre-lab. So you'll just basically turn in the reaction table part, the data table part as part of your report. So for this lab and all future labs, what you'll essentially have to do is just turn in the parts that you write on. So just like normal, I don't need all the introductory parts, all the procedure parts. I just need the parts where you have written on. I'll get to your question about homework in just a second. So in terms of the lab report, once you've filled it in, just like you normally would, what you then have to do is basically scan it in and upload it through Canvas to turn it in. Now, there's a couple different ways you could do that. If you have a method to do that, a scanner, you can do that. But there are some phone apps. For example, Adobe Scan, I believe, has a free phone app for both, I think, Android and iPhone. So if that's easier for you, you could probably download that. And then once you're done, you can scan in all the pages and it will turn it into a PDF file, which you can then upload. Or you can use any program you like to do that. But you do need to kind of, if you could, for me, when I'm going to grade it, it would probably be easier if you could kind of get them all together in one file, all the pictures, if you take pictures or scan it into some type of PDF file or some file like that, where I can just kind of open it and see everything like it would be on the page. So you're going to watch the video. You're going to go through all this stuff. You're going to fill it in. Normal labs outside of this, like we've seen in the past, will have some post-lab questions as well. So obviously those would need to be answered and turned in as well. Where you're going to turn all that in once you've got it converted into a file is right here. So I included a link to the assignments. So you can either go through here or you could go to assignments, but if you click here, it will take you to the assignment page on Canvas. And that will allow you an opportunity to basically submit your paper and upload your file when it comes in. So right here again, if you hit submit, it will tell you when it's available to do so. It'll also tell you when it is due. And again, if you just hit submit, it will ask you obviously to choose a file, and you can then submit your assignments. So that's essentially how labs will be done here. And it will be done through Canvas. You'll basically watch videos / PowerPoint sort of presentations, and then you'll be able to fill out the lab report just like normal, upload it, and submit it through Canvas. So again, there will be due dates, so you want to make sure that you obviously get those things submitted by the appropriate time. Any questions on the lab sort of portion? Okay, so to answer the question about the homework, currently the homework's due date, I think might have been the end of this week or something like that. So since I did postpone the exam, it will be due probably next week. So it'll be due Monday, I think. Hopefully you've been working through some of that stuff. Again, don't wait till the last minute. There's a lot of questions, but I think I will move it to probably next week. I did postpone the exam until I believe next Monday, if I'm not mistaken. I think that's what it said in the announcement. And again, that's just going to give me a little bit more time to prepare it. All my schools went online pretty much all at once. So I'm sort of catching up with all that. So in terms of the exam, how it's going to be is, I think at this moment, and again, I'll give you more information about it as the week goes on. But my thought process right now is that the exam is going to be done through Canvas, and kind of like a quiz or that type of function. You'll log on to Canvas. The exam will be available for a certain period of time. My guess it will be available during our normal lecture time and maybe through our lab time as well. So you have, say, starting at 10:30 on Monday to log into Canvas to take the exam. Just like our regular exam, there will be a time limit as to how long you have to actually take the exam. So it's been a while since I've done something in Canvas, but I think they give you like a countdown timer or something like that. So when you click on the exam, again, you'll have a certain period of time to do the actual exam. Now, because the exam is going to be done online through Canvas, obviously, if you've taken quizzes or stuff through Canvas like that, it's pretty much you have to enter an answer for the most part, unless it's kind of like a short answer type question. So because our class is a chemistry class, and usually you get some partial credit for showing your work and stuff like that, I believe there's going to be that aspect of it as well. So as you're taking the exam, you are going to probably have to show your work on a piece of paper. That way you can then submit it when the exam is over. So you'll have a certain period of time to actually take the exam online. Once you've completed the exam online, you'll have a certain amount of time to basically scan and upload your work for the exam. That way, at least if you press the wrong answer or enter the wrong answer, or get the answer wrong, I can at least look at the work that you did for those questions that had work associated with it. And that would allow me to be able to maybe give you some partial credit, stuff like that. I'll get to your question about the lab in just 1 second. So that's how I'm going to envision how the exam's going to happen. You'll do it through Canvas. You'll basically submit your answers through Canvas, and then you'll have an additional little bit period of time to scan in your work. So I can at least look at that and sort of, like I said, if it's possible, give you some partial credit on that. Again, everybody will have a certain time limit. If there's anybody that has some accommodations through DSPS, we will do our best to adjust your time accordingly to your accommodations. And again, you can privately contact me about that. You don't have to do it through the chat or anything like that. But we will take care of you that way. So a couple questions. Yeah, so a couple questions about the exam. I probably will give you a little bit more time to take the exam. I know it's online, so it's going to take a little bit more time, but you won't have like hours and hours to take it. So it'll be within reason. Our normal sort of time limit, which is usually about an hour and a half to take the exam, probably plus a little bit more time because it is being done online. And then once you've completed the actual testing part, you'll be able to then have another period of time in which I will accept the work for the exam to be uploaded and sort of shown, submitted through the assignment section. In terms of when the exam will be available, again, because there's a lot going on for people, I mean, make the exam probably available when normally our lecture period would start, and it probably will still be available to take probably through the lab time as well, or at least start it in that sort of window. So that gives you a pretty good window to sort of start it. But it'll be something like that. I haven't 100% finalized everything. Everything sort of happened really quickly, but that's sort of my goal as to what's going to happen. So I think I think it will start somewhere in that area that when you'll be able to take it. And again, that may change, and I obviously will update you as the week goes on and as I sort of finalize things. So I may open it at 10:30, which is what I'm originally thinking, but I may open it at 12 as well. But I'm trying to think about exactly what would be best to sort of open those things. So still working out some of the details, but that's the overall how the exam will probably look come next week. And like I said, as soon as I sort of finalize some things, either on Wednesday during our lecture, we'll talk more about it, or obviously I will post things on Canvas to give you an idea as to how it will all work. Any questions on that? So my vision for lab is on most cases, since you will be looking at videos and watching videos and stuff in place of physically doing the labs, what I'm also going to do probably on both days, Monday and Wednesdays each week, is again, I will open up a separate lab sort of meeting online here. And what it'll pretty much do for the most part, I think, unless there's something we specifically need to discuss at the beginning, I'll be available to answer questions. So if you have questions about calculations in the lab, or if you have questions about something that's related to that week's lab that you're doing, that would be a time where you can sort of ask me those questions, and I'll just kind of be available to answer your questions, much like I was normally available at the front of the class. You could come up and ask the questions during lab time. I think I'll open that lab section at 12 o'clock where we normally meet. And again, you can go watch the video during that time. You could come back and join back into the meeting if you needed to. And again, you could ask questions if you need to. So my recommendation in terms of the labs as we continue on from this point is to try to probably watch them after we're done with our lecture here around our normal time as well. If you could do that, again, because we'll have that lab section where you basically can pop in if you need to ask questions and get help on those things. For this first experiment here, experiment 14, I'm going to make do on Wednesday by 12 o'clock, which is when our lab would normally start on Wednesday. As we go on from here with future experiments, they may be due by the end of the day as well, or the beginning of the next day. So again, I would strongly encourage you both to continue to attend the live lectures and also continue to attend perhaps the live lab sections, especially if you have questions. Or again, the nice thing about this is you could drop off and then the meeting's still going on. You could hop back in and ask your question and sort of get help that way. So most beneficial if you could still do it. And like I said, I understand a lot of things have been changing, but if you could still show up here during your regularly scheduled time, that would probably be best for you, because that's really your place where you could kind of get in touch with me or ask me questions. Any questions about sort of the class or anything like that in terms of how we're going to proceed? Also, a reminder that my email address, right, this hasn't changed, so you could still contact me through email any day you like, Mondays, Wednesdays, Tuesdays, Thursdays, all the way through the weekend as well. Seems like I'm always checking all my emails now nonstop. So I will get back to you. If I don't, please be patient or send me another email. I'm sure just like your inbox, my inbox is pretty much, blown up with lots of emails every second. So, it's possible I may actually miss your email in there, but I usually will be able to find it. But just in case, if you don't hear back from me, within the day or normally when I would get back to you, a time period, just shoot me another email. That way I'll be sure to see it. But that's also another link where you can still stay in contact with me, and we can kind of communicate even when we're not lecturing. Any questions on the class or any of that type of stuff? So again, you want to make sure that you continuously sort of check Canvas, both the announcements, the module section, that email that's associated with it, so that you will always be able to sort of be up to date on everything. Any questions? I'll leave this up. Okay, so we're going to continue to lecture. And as we continue to lecture, again, a reminder that all the lecture notes, just like they've been from the beginning of class, are still posted up online in that module section. So if you want to download them and use them as you're listening to this live, or if you're listening to the recording, you can do so. Everything that I sort of scribble on the screen, you will also be able to see in the recording as well. So that's nice. That's a nice thing as well. So last time, I think before spring break, we got through chapter 6, if I'm not mistaken. And chapter 6 was about balancing equations. So I believe we talked about how to balance an equation. Remember that when we do look at an equation, say something like CH4 plus O2 makes CO2 plus water. That when we balance an equation, the important thing is to only change those coefficients. So it should only be the coefficients that we change. We never change any of the subscripts that are in the bottom. We never put anything like in the middle in terms of numbers. It is only those coefficients that we change. So when we do something like this, again, sometimes it's good to make a table. Like we have our reactant side, our product side, we have our carbon, our hydrogen, and our oxygen. On the left-hand side, we have one carbon. On the right-hand side, we also have one carbon. Left-hand side, we have 4 hydrogens. Right-hand side, we have 2 hydrogens. Left-hand side, 2 oxygens. And right-hand side, 2 oxygens here, plus 1 more, which is 3 right there as I scribble over that. So this table sometimes will give you a nice place to sort of start with. So for example, the carbons are balanced. So we could go to the hydrogen, and to balance the hydrogen, we would need to put a 2 in front. And when we put a 2 in front, that now gives us 1 carbon. It gives us 2 times 2, which is 4 hydrogen, and 2 oxygen here plus 2 more here gives us 4 in terms of the oxygen. So we can see now carbon's balanced, hydrogen is balanced. We then could go to our oxygen. We have 2 on the left-hand side, 4 on the right-hand side. So to balance that, we could finish by putting a 2 there in front of the oxygen. That gives us 1 carbon, gives us 4 hydrogen, and 2 times 2 is 4 as well. So this would represent our balanced chemical equation. Remember that when you balance a chemical equation, you always want to have a couple things at the very end that you need to have, which is you need to have all whole numbers. So you have to use all whole numbers when you balance an equation. And then it has to also be the simplest set of whole numbers. So as we might have talked about last time, a reminder that if you were to balance an equation, something like this, 2a plus 4b goes to 6c. Although it may be balanced, if we assume this is all balanced, we could reduce all these guys down really by 2. So if we divided it by 2, we would end up with a plus 2b gives you 3c. So this could sometimes happen. So as you are balancing an equation, you may see larger numbers when you balance the equation, and that will maybe still be balanced in terms of, hey, there's 4 carbons on this side, 4 carbons on that side. But if you can, at the end, when you're done balancing, reduce down all of the numbers by a common number, you should do so. The other thing that we talked about when we were talking about balancing is you can use a fraction to balance. And sometimes you may have to use a fraction to balance an equation. But if you do use the fraction, so for example, let's just say you used 5 halves to balance something. Say you had 5 halves O2. Although it may be balanced in that equation, you cannot leave it as a fraction. So you would have to multiply not just the O2 in this case, but everybody by that 2 to clear the fraction as well. So again, let's just pretend this one did. It doesn't. This is not correctly balanced. But let's just say we use 5 halves here. To clear that fraction, again, we would need to not click the wrong button. Let me try that. Come back. We would need to multiply the entire thing by 2, and that would give us obviously 2CH4 in this case, plus 5O2 goes to 2CO2 plus 4H2O. And again, that's obviously not balanced. I was just using it as an example to clear the fraction. This is clearly would be wrong in terms of balancing, but again, the idea is sometimes people want to just clear the fraction part of it, but you do need to multiply by the denominator all the way across. So if I'm not mistaken, I believe we talked about all types of balancing. Also remember that if you do have some of those polyatomic ions in those equations, sometimes it's easier to balance those guys as sort of whole units rather than sort of individually by each of the elements that are present. Any questions on any of that? Okay, so with that being said, so since we've talked about balancing, we are going to move to the next chapter, which is chapter 7. And again, a reminder in terms of the exam that's happening next week, it is still on the chapters it was previously. So chapter 6 that we started before spring break, along with this one, which is chapter 7. And then I think we go 9 and 13, I think, next. Those chapters will be on the exam number 3. So nothing that we're talking about today or anything that we talked about in chapter 6, which was essentially balancing, will be on the exam next week. It will still be on those previous chapters, just like it was normally scheduled. Any questions on that? Okay. So now that we talked about how to balance equations and reactions, we're going to actually talk about different types of, so in this chapter, we're really going to talk about different types of reactions. And when we talk about reactions, there's a lot of ways that you can sort of classify a reaction. And what we will see is you can kind of classify a reaction in multiple ways. And even the same reaction can be classified in different ways, depending on sort of what aspect you're talking about. So as we go through this, we'll talk about those different sort of classifications and different ways that the same reaction is sometimes classified. Um, and let's take a look here. So the first thing we're going to talk about is aqueous solution, and a couple of reminders that when we talk about an aqueous solution, there is a difference between something that has the L, which is liquid, symbol next to it, and something that has the aqueous symbol next to it. So when we talk about L, that is typically just a liquid. So that is something by itself. For example, water. So if we had just water, H2O by itself, that would be classified as a liquid and would have that L symbol next to it. Now, aqueous over here is different. Aqueous is basically usually referred to as a solution. And usually what that means is you take something, for example, you take something like sodium chloride, that's a solid, and you put it into some water, that's a liquid. And when we would mix these guys all up together, we will end up getting a sodium chloride solution. And that is where we would typically use the aqueous symbol. So usually the L symbol or liquid is basically reserved for things that are just by itself, nothing else mixed in there, basically one substance like water. The AQ or aqueous symbol is essentially used for when we take something, a lot of times a solid like sodium chloride, and dissolve it in something like water, and we make it. When we talk about a solution, there's two parts to a solution. There is the solute, and the solute there is the smaller part of the solution. So the solute is the smaller part. And it is usually dissolved in the second part of the solution, which is known as the solvent. So the solvent is the larger part of the solution. So in the above example here, the sodium chloride is the solute, and our water is our solvent. So in our example here, this would be our solute, and our water would be our solvent. And the easiest way to recognize what is a solute in a solution is pretty simple. It is actually the name of the solution. So somebody says I have a sodium chloride solution. The solute is sodium chloride. If somebody says I have a hydrochloric acid solution, the solution and the solute is the hydrochloric acid. A lot of times the solvent and a lot of things are water. Water does not always has to be the solvent, but in a lot of cases it is the solvent. It works really well with things that are polar or ionic. So these things work really well with a solvent like water. And again, it's because they're able to interact really well with each other. Water is a polar molecule, as we talked about. Um, it's able to basically do some hydrogen bonding between something else that's polar, something else that's ionic. So those things work really well. The solvent does not always has to be water. It can be something else, but a lot of times it is water. As opposed to, say, something that is more non-polar. So if you had a non-polar molecule, say like Br2, it would probably use something that's a non-polar solvent. So if you remember, we did that experiment where we had bromine water, iodine water, chlorine water, and we mix it with like hexane. And we ended up getting two types of layers when we looked at the test tube. The top layer is where the halogen was, which is like, say, the Br2 in this example. And that was I believe it was hexane we used. And hexane is a nonpolar liquid, and that's why our nonpolar Br2 was here. If you remember, the bottom layer was basically our aqueous layer, our water layer that was there. So we sort of saw a little bit of that when we did that experiment earlier on in the semester. Things that are nonpolar like Br2, Cl2, those guys are typically more soluble in a nonpolar solvent, while things that are ionic or polar would be more soluble in a polar solvent like water. And it brings up the idea of, in terms of solubility, like dissolves like, as we'll talk about here. So things that have similar types of ways to interact with each other are able to interact well with each other. Things that have very different ways of interacting with each other are not able to interact really well. And when we talk about certain things and solutions, certain solutions are basically what are known as electrolytes. And electrolytes, again, there's a couple of different ones. There's a strong electrolyte, and a strong electrolyte pretty much means 100% of it breaks apart into ions. So if we had something like what we have down here, here's some examples of some strong electrolytes. They're pretty much ionic compounds. So if we had something like sodium chloride in solution, or if we had a solution of sodium chloride, what's essentially going to happen is when that thing is in solution, it will break apart into sodium ions and chloride ions. And in a strong electrolyte, you have 100% these ions that are present. You no longer have any of the sodium chloride units still left in a solution. So 100% of them break apart. And what makes something an electrolyte is something that will produce ions. And when it produces ions, is able to conduct electricity really well. So a strong electrolyte can conduct electricity very well. So a common example is if you take like a light bulb that has some electrodes, you stick it into a solution that's a strong electrolyte, that light bulb will go off very brightly. So it'll be very, very bright light bulb. And it's conducting electricity really well. It's able to do that because you're basically generating a ton of free ions in that solution that's floating around. And that's different than, say, a weak electrolyte. In a weak electrolyte, say something like hydrofluoric acid, it will still break apart into H plus and F minus. And although it still breaks apart, the difference here in a weak electrolyte is you have just a few of these guys. You mainly have this guy still together. So in that solution of, say, HF, you mainly have that HF unit still together, but it's able to produce a few ions. Because it's able to produce a few ions, it's able to still conduct electricity. But it cannot conduct electricity anywhere near like a strong electrolyte. So for example, if we talk about our weak electrolyte, we put that same light bulb with those electrodes into that solution. What you would see is the light bulb would still go off, but it would be very dim. But it's still able to go off and conduct some electricity because it still has some ions floating around in that solution. But mainly what you got going on there is that HF unit still together. And the way you could recognize that a lot of times in an equation is by the arrows. In a weak electrolyte, in our weak electrolyte here, we see these arrows heading in both directions. So that implies a reversible reaction. And that means that there is a direction that goes in this way, which is the forward direction. And there's a direction that heads the other way, which is the reverse direction. And that basically means that this reaction is heading in both directions. But usually in a reversible reaction like that, what we mainly have are reactants. We have a little bit of those guys still basically produced. And that is different than, grab a different color to mix it up here a little bit. And we'll go green. So that is different than definitely over here, where we have our strong electrolyte and a strong electrolyte. It is one-way street. Cover a little bit. It is heading from reactants to products. So that's the main difference that you'll see in terms of the arrows. If you have a one-way arrow heading to the products, it's going to be probably a strong electrolyte if it's an ionic compound. If you see these arrows heading in both directions, that's a very big hint that it is essentially a weak electrolyte. Still able to conduct electricity, but again, nowhere near what a strong electrolyte could do. The last type of electrolyte is a non-electrolyte. And in a non-electrolyte, you will get something to dissolve. So for example, if we took sugar, that's a solid, and we dissolved it in water, we would get that sugar to dissolve. And although it does dissolve, and as we know, we've seen sugar dissolve, although it does dissolve, the difference here is we get no ions. And that's because basically sugar is carbon, hydrogen, and oxygen. So basically carbon, hydrogen, oxygen, that's going to be molecular compound. That's going to be covalent bonding and sharing of electrons. So because we don't produce any ions here, we're not going to conduct electricity. It's not going to sort of complete the circuit. And for example, if you put the light bulb there into your non-electrolyte, basically the light bulb would not turn on because it's not conducting electricity. So to summarize sort of the differences in electrolytes, a strong electrolyte, one-way arrow heading to the products. Usually your ionic compounds are strong electrolytes. When they're in solution, they're 100% broken apart into ions. Conducts electricity very, very well. Our weak electrolyte typically can be seen by those arrows heading in both directions. Pretty much stays together as a whole unit, but still able to produce a little bit of ions over here. So again, because it's able to produce a little bit of those ions, it's able to conduct electricity. And lastly, our non-electrolyte here, also a one-way arrow typically. The major difference is right here. It will produce something that does not produce any ions. So even though something like sugar will dissolve, no ions are being produced. No ions are being produced means, again, no electricity, basically, not conducting electricity. Any questions on the differences between strong, weak, or non-electrolyte? And again, a reminder as we go through this, if you do have questions, you could type it in the chat. You could also raise your hand and I'll come to you if you like, but probably the chat is the best way there. And again, that's pretty much what I just written. I scribbled over it. So water, as we've talked about, again, is a very good solvent for a lot of polar things because it does have a positive side and negative side. Yeah, so a question is about the strong and weak electrolytes. It does have to do really with the differences in conductivity. A strong electrolyte, and really the reason it's able to conduct electricity really well is really because it will break apart in water and it will produce pretty much a lot of ions, 100% ions, and all those positive, negative ions that are floating around helps conduct electricity. A weak one still going to produce some ions, but it's going to produce a little bit of ions. For the most part, again, if we go back and just kind of look at that what we were scribbling when we looked at our weak electrolyte. In solution, this is pretty much what you have. It's pretty much all that. You have just a little bit of these ions over here, but because they're still able to produce a little bit of ions, it's able to still conduct electricity. But again, in terms of the light bulb example, it would be pretty dim because there's just a few of these ions kind of floating around freely, as opposed to our strong electrolyte up here, where there's a lot of ions floating around in that solution, and it's able to conduct electricity very, very well. So strong electrolyte, we would expect to see really that light bulb go off very brightly, while our weak electrolyte still going to conduct electricity, still going to go off, but going to be very dim in sort of comparison to it. Other questions I can answer. So as I said, water is very good conductor of electricity, again, because it's polar. And a reminder that polar, right, basically means that on water, for example, there's a positive side to water and a negative side to water. And the hydrogen side of water is more positive. The oxygen side of water is more negative. And pretty much they're able to interact with each other through basically the simple idea of opposites attract. So as we'll see, I think on the next page, if you take something like sodium ion, it basically will be attracted to the oxygen in water. So water will basically surround the sodium ion with the oxygen side, which is its negative side. Remember, opposites attract, and so forth there. And the same thing would happen with the other ion in sodium chloride. So if you had your chloride ion, just juggle a couple of boxes off my screen here. There we go. So if you had your chloride ion here, it also would be surrounded by water, but it would be surrounded by the hydrogen side of water, which is its positive side. And that's essentially, as we'll talk about, what allows both of these things basically to dissolve. So when you put something in water like sodium chloride, it's going to break apart into those ions. They're both going to get surrounded by water. And it's really those ions being surrounded by water that makes it look to us when we look at it, wow, it just kind of disappeared. It's gone. It just went away. And it really didn't go away. It just really got trapped in all those waters. So visually, we no longer can kind of see the big sodium chloride still together in a solid version. It gets trapped into water and it sort of disappears and dissolves. These waters also serve a function to basically keep these ions apart. And again, if those waters were not there, those ions would be super attracted to each other. So that positive charge and that negative charge would want to come back together. So also, I think we did an experiment earlier on in the semester. You had a solution like this, and then as you started to heat it, for example, you took that sodium chloride solution and you heated it. And when you heat it, right, all of those water molecules are essentially going to evaporate away. And as they evaporate away, essentially what's going to happen, right, is these water molecules will all sort of evaporate. And that's going to allow the sodium ion, which is really attracted to the chloride ion, basically to come back together. And that's when we see, like we did in those experiments, the solid sodium chloride come back. So like in your evaporating dish, when you made those water baths and you evaporated off the water, when you're left was basically a residue, like a white residue, which is your sodium chloride that basically came back. Any questions on that? So this is just a nice picture of what we just talked about. Again, the process where those ions basically get surrounded by those waters is sometimes referred to as the process of hydration. Again, because we're basically surrounding or adding water to it. And again, those waters do serve, as we just talked about, kind of two purposes. A, it allows an ionic compound like sodium chloride to dissolve. And B, it also prevents those two ions from coming back together. Because those ions are attracted by that electrostatic attraction, which is a very strong force, they would definitely, when the water is gone, want to come back together. And again, in terms of practical application, that's what you saw when you had in your evaporating dish, that white solid that still appeared after you evaporated off all the water. So when we talk about acids and bases are also can be electrolytes. And it works the same way. If we have a strong acid or a strong base, they will be considered a strong electrolyte. So for example, over here, as we remember from our nomenclature, right, HCl is hydrochloric acid. A reminder, right? No oxygen here, so it starts with hydro, ends with ic, so hydrochloric acid. And when we do have a solution of hydrochloric acid, which is a strong acid and also a strong electrolyte, when it is in solution, much like we were talking about, what we'll essentially have is, again, 100% these ions. So you no longer have any H and Cl units still together. And basically what makes something an acid, as we talked about, is the ability to produce H plus ions in solution. So when it's able to produce H plus ions in solution, it's considered an acid. And because something like this, which is a strong acid and 100% breaks apart into H plus and Cl minus, it produces a lot of free H pluses very quickly. And that's what makes it really a strong acid, which is also a strong electrolyte. And that's different than, say, a weak acid like the one we just were talking about, which was hydrofluoric acid. Another example would be what we have here on the screen, which is acetic acid. So acetic acid looks like this. Again, it could also be written C2H4O2, or it may even be written C2H3O2H. Remember, as we talked about with formulas, sometimes they are written in a couple of different ways. Some give you more information about how they're connected, and some give you a little bit less information about how they're connected. We know that this acid, which is basically what vinegar is, the major component of vinegar, which is acetic acid, we know from looking up this that it is a weak electrolyte and also a weak acid. Again, because of what we were just talking about, we see those arrows basically heading in both directions. So since we see those arrows heading in both directions, what is going to happen is it's going to produce a little bit of these guys. But mainly what you have in solution is still that whole unit still together. So this guy's going to mainly stay together. And that's what makes it a weak electrolyte and also a weak acid. It's still considered an acid because you're still producing a few of these free H pluses, but nowhere near what you're doing up here in terms of our strong acid. But because it's able to still produce a few of these H pluses, it's still considered an acid, but it's considered a weak acid. So your basic definition of acid is right there. It's that ability to produce H plus. But depending on how much H plus is produced, as in terms of is it a strong acid or a weak acid? Any questions on that? So let's start with the first type of reaction, which is a precipitation reaction. And a precipitation reaction, much like it implies here, will produce a precipitate. And a precipitate is sometimes abbreviated as PPT, and that stands for a precipitate. So a precipitate pretty much means that a solid is formed. And that's usually a result of mixing two solutions together. So when we produce a solution and we take two solutions and mix them together and they produce that solid, that is considered a precipitate reaction. Again, when we talk about a precipitate being made, sometimes people think it has to be like a rock hard solid that's been made. that, just falls, for example, to the bottom of the test tube or the beaker that you make. And it doesn't always have to be that. A a precipitate can be a solid that's formed. It could be something as simple as the got cloudy. Um, some particles appeared that wasn't there originally when you mix those two solutions. So again, when we mix a couple of solutions, usually maybe more, we get some type of solid that's formed. And again, like I said, it doesn't always has to be like I got this rock that kind of falls to the bottom. Again, it could just look like something, it started to get a little bit cloudy, that wasn't there before. And those are all evidence of a precipitation reaction taking place. As we'll talk about a little bit later in this chapter, and just to kind of preview, and again, don't hit the wrong button, sorry. To sort of preview is that this type of reaction is also a type of reaction which is referred to as a double displacement reaction. And essentially in a double displacement reaction, as we will definitely see a little bit later on, the way you can recognize it is pretty simple. You will have two things on your reactant side, and they both will be ionic compounds. So you'll have something that's positive and negative. This guy will be positive and negative. And what ends up happening is these two guys basically will switch partners. And when those two positive guys basically switch partners, we will end up with a new ionic compounds formed on the other side. So we'll have A and D that will come together, and we'll have C and B that will come together. Again, this guy would be positive, this guy would be negative, this guy would be positive, and this guy would be negative. So this is one of those places where you will see that in certain cases, some people will call it a precipitation reaction, and some people also call it a double displacement reaction. They're both really okay classifications for the same reaction, as we'll see some examples in just a second. But you can always classify reactions sometimes in multiple ways, depending on sort of what you're looking for. And what, again, will make this really a precipitation reaction is one of these guys will make a precipitate. So you'll have some type of solid form. For example, say this guy, when those two things come together, for example, will make a solid. And we're going to talk about in this chapter as well, in just a little bit here, what you could use to help you determine whether or not, if you put these things together, you make a solid, or if you put these things together, you don't. And we touched a little bit about it, I think, in an earlier lab. It was like a post-lab question, had to do with what's known as solubility rules. So we'll get to all that as we go through this chapter. Any questions on that so far? So a precipitation, as I mentioned, reaction involves really the formation of an insoluble product, which is known as a precipitate. And that usually results really just from mixing two solutions together a lot of times. The combination of ions that are floating around there. So as we were talking about before, really when you have a solution kind of floating around in there, you have certain positive cations that are floating around. And you got certain negative anions that are floating around. And when you mix it with another solution that also has some cations and anions floating around, you can get a precipitate to form. And again, a precipitate is abbreviated as a PPT, is basically what a precipitate means. And to answer your question, Grace, let's see, oops, too far, come back. What it means in this type of reaction, what makes this type of reaction a precipitation reaction, is that either this guy or this guy, usually one of those guys, those combinations, when they come together, will produce a solid. And that's again known as a precipitate, which is sometimes abbreviated as a PPT. So that's essentially what that means, is just a mixture of these two combination of these two ions will either form a solid, or the combination of these two ions will also form a solid. Any questions on that there? So again, when we form that precipitate as a result of taking kind of two solutions, which again, they both have those positive guys floating around, there's negative guys floating around. And again, it's really this combination of a positive and negative guy coming together, a negative and positive guy coming together, that will make those solids and a precipitate that forms. So here's an example of a precipitation reaction. And if we look at this reaction, and I will, as I move some boxes around here so I can see what I'm looking at. So when we look at this reaction, this is a classic precipitation reaction, and it really is a double displacement reaction. So this is lead 2 nitrate, and lead 2 is positively charged. Nitrate is negatively charged. This guy is sodium iodide. He is positively charged. The iodide is negatively charged. And really what's going to happen here is, as we will see as we go through this, these two guys are going to switch partners. So what happens is, on the other side there, the lead will then hook up with the iodide. Switch out the color here. We'll go red. So the lead here will then come together with the iodine, and that's really how we get to this guy over here. He will be a guy with a +2 charge, like he has over there, coming together with something with a -1 charge. So remember that when we put together our ionic compound, we want to balance out the charge. So that is how we get to the two I's that we see here. So remember that in something like this, if you are to predict what's on this side, you want to start with the basic ions that make those guys up and put them together correctly in terms of those ions, positive and negative with no charge. And the same thing will happen now if we take our other two guys that are there. And if we go over here, our sodium will now hook up with our nitrate. And that is essentially how we get to our sodium nitrate over here. Again, when we put this together, sodium is a +1 charge, even though there's like 2 in front of it, for example. And our nitrate is a -1 charge, again, even though there's 2 on this side. So when we put those formulas together, +1 and -1 gives us our correct formula that's on this side, which is NaNO3. So this is your classic double displacement reaction, and really was referred to as a precipitation reaction, because when you do that combination together, the combination when a lead with a +2 charge and some iodide come together, those combinations will produce what is known as a precipitate, based on solubility rules that we'll talk about in this chapter as well. And that is different when we put together our sodium and our nitrate. When we put our sodium and our nitrate together, those two guys will be soluble in each other. And that basically is why this guy ends up with a aqueous symbol, while these guys will make a solid. And that is why he ends up with a solid symbol. And that is your precipitation reaction. And when we look at the equation that is up there, this equation that's up there was referred to as the molecular equation. And the molecular equation is one where we write everything out in terms of its formulas all correctly. And we don't show charges, we show everything in their complete ionic form. And a lot of times, though, when we do look at a reaction like this, that doesn't really adequately explain what is going on in solution. So we can basically take the same equation here and write another equation that will really sort of show us what's happening in this solution. Because this is aqueous, something like the the lead will break apart into lead with a +2 charge and will be aqueous. And that comes from over here if we take this guy first. It will also produce two it'll produce two of the nitrates. Sorry, let's try to get my boxes out of the way here so I can write. There we go. And it will produce two of these nitrates, which will also be aqueous. And that comes from here. So when we break it apart, the two will come in front of the nitrate, and that's where the two comes from here. This will also break apart the sodium iodide into two sodiums. Again, here we're going to distribute the two to the sodium. We'll also have to distribute the two to the iodide. So we'll get two of the iodides. What I'm going to do is I'm just going to go this way and write the rest of it. And when we come to this side, when we write it this guy, because this is a solid, so for example, if you think about it in the test tube, it's sitting there perhaps like on the bottom or together, it's actually going to stay together in that solution. And that's why we could see it in the solution as a solid. So we don't break apart anything that has a solid next to it, so it would still stay together. So anything with a solid or even a liquid symbol next to it will stay together when you write this type of equation. And the next thing that we have is our sodium nitrate, which we also need to, again, distribute this to. And when we do that, we will get two sodium ions plus two nitrate ions as we distribute that to. Now, this equation that we see here represents truly what's happening in this solution. And this type of equation is what is known as a total ionic equation. And are just called ionic equation, but most people call it total ionic equation. And when we take a total ionic equation, it's an equation that basically represents what is truly happening in that solution. So when we look at our total ionic equation here, we will see certain ions that are on both sides of the arrow. So if we take our nitrate, for example, and we take our nitrate on the other side of the arrow, they look exactly the same. And if we look at our sodium over here on the left-hand side of the arrow and our sodium on the right-hand side of the arrow, they are also basically exactly the same. They look exactly the same on both sides. We have two NO3s, two NO3s, two Na pluses, two Na pluses. These guys that are basically just kind of hanging out, not really doing much, these are what are known as spectator ions. And basically spectator ions, much like the name implies, are hanging out. They're not really producing the product that's happening in this reaction. They're really not producing the product of the reaction. They're just watching, really. So once we write our total ionic equation like we did here, what we typically do is we find our spectator ions and we essentially will cross them out. So you can think of the arrow almost like an equal sign in math, that if you have two things on opposite sides of the equal sign, you basically can subtract it to the other side and cancel them out. And what that leaves us is another type of equation, which is really what is happening in this reaction. We're left with the lead 2 plus the 2 iodide guys. And again, that comes from right here and right here. And what that produces is our lead 2 iodide, which is a yellow solid. And right, so the question is, I believe spectator ions are just floating around in the solution. They pretty much are just kind of hanging out really to balance out the charge of all the ionic compounds that are in there, but they do not produce any product that's happening, the actual product in this reaction. So what I mean by that is in this reaction, the overall reaction that's happening is really here. So the overall product of what I'm talking about in this particular one is the lead 2 iodide. The nitrate, the sodium really is not producing the actual reaction that you would see. So for example, if you dump this guy here, the lead 2 nitrate and our sodium iodide in a beaker together, what you would see really in that beaker is a yellow precipitate of lead 2 iodide that's formed. And that is truly what the reaction that's happening in that case is the formation of that lead 2 iodide. So when we talk about our spectator ions, although they are still in that solution, they're still at that point floating around in that solution. They're not really participating in the formation of the actual precipitate in this reaction. So that's what I mean by that. They're technically still there in that solution, in that test tube or beaker that you had. For example, if you made that solid, you might still see some kind of liquid part that's still there. And that would be where you would still find your spectator ions basically floating around in that sort of liquid part of it. And when we get down to this reaction down here, or equation down here, where we've gotten rid of all the spectator ions, this is a third type of reaction, which is known as the net ionic equation. And the net ionic equation is the equation that basically tells us exactly in this reaction when we, for example, here put our lead 2 nitrate together with our sodium iodide, what is actually happening is these two ions are coming together to produce this solid. So when we look at three types of equations, oftentimes with double displacement reactions, are precipitation reactions, which oftentimes are the same. There is the molecular equation, which is basically this one right here, where everything's written out like normal. There is our total ionic equation, which is this one, where we break apart everything that can be broken apart. The only things that we do not break apart are liquids, solids, are weak electrolytes. So if you have one of those three things, liquid, solid, or weak electrolytes, when you come to the total ionic equation, you should keep those things still together in their whole formula, like we did down here. And then we want to find our spectator ions, which are the same ions on each side. We want to cancel those out to give us our third type of equation, which is our net ionic equation, which is truly the reaction that is taking place in this case. Any questions on that? Or anything we talked about today? Okay, a couple of things before we end officially the lecture portion here, since we're towards the end, I think. Again, a reminder that we will have lecture at a normal time, 10:30, Monday and Wednesdays. We will also have our lab section starting at its new time, at the same time, which is 12 o'clock. Again, in terms of the lab part, today as well, I'm going to open up the lab meeting after I close this one. So if you want to get to the lab meeting, you need to go back through Canvas and click on the one that says lab. And I'll be there during our normal time of like 12 to 1-ish, 1:20, something like that, wherever we usually meet till. And again, you could use that time to hop into the meeting, ask questions if you need some help. I would recommend at this point, after we're done here with the lecture, that you go through Canvas and maybe watch the video, try to do the lab. Again, if you have questions, that will allow you to hop back into the lab meeting and get your questions answered. Again, a reminder, the link, as I showed you earlier, is on Canvas. You can watch the video. You fill in the sheets just like normal. And just like normal, I just need the sheets where any part of the experiment where you actually wrote. You need to, again, scan that, kind of save it as a file. Maybe a PDF file would be good. And again, through the assignments or even on the where the video is, you can upload that and submit it. Experiment 14, again, since this is our first time doing all this, I'm going to give you until Wednesday at about noon to submit that. And you can submit it through that. Any questions on anything? So a reminder that these will be posted up online, a link to these lectures and stuff like that. And it does take a little bit of time to process them, but they hopefully should be on there and you'll be able to find a link. Yes, Grace, what's up? Do you want to type your question, Grace? Yeah, so the question is, are you submitting? Yeah, so my understanding what you have to do in terms of that, just so we're clear, is just like normal. So either if you have, in terms of the lab, if you have the lab manual, just like normal, the actual physical one, you got it like Office Max or whatever it was, Office Depot, you could fill it in just like you would with a pen and pencil or paper or whatever you want to use there, crayon, I suppose. And then after you're done filling it in, either from the manual you got at Office Max, or you can still go up online at the chemistry webpage for Saddleback and download the experiment under experiments and fill it out again with pen. After you're done filling out from watching the video, you then could scan it, and then you need to upload individually a PDF file or some type of file like that would be good through the assignment page. So when you go to the assignment page, if you just go to the assignment section, there'll be one that says, for example, experiment 14, and then you just hit submit and it'll prompt you to upload that file. Or again, you can also get to the assignment page through the actual video link as well on the module section. Will take you there. Other questions on any of that? So again, I would highly encourage you to kind of do the lab now. Again, if you have questions, that way you could ask those questions. Again, a reminder of stuff that we talked about, just in general in terms of the class. The exam will be next week, and as I'm envisioning it now, will be done through Canvas, where you log in and do the exam. And then at some point, kind of like how you're going to submit your lab today or tomorrow, whenever you get it submitted, you will upload your work for your exam to show it. And then that's how the exam will take place. Again, you'll have a certain period of time, probably a little bit extra because it is online, but it will be available for only a certain period of time on Monday for you to take it. And then you'll have another period of time to upload that work. In terms of the lab, they will probably proceed much like today's. Again, we'll open up a lab section for questions and if you need help. And again, if you don't, then you could just submit all that kind of stuff up online. And again, pre-lab assignments are still due the day of the experiment, so make sure you do those. I don't know if I'll get to it today, but hopefully by the end of the day, I'll extend today's and reopen it if you need to do today's if you missed it. But in the future experiments, just like normal, the pre-labs need to be done the day of the experiment. As of now, my understanding is we're going to try to hold to the lab schedule that we currently had. So we're going to try to keep that lab schedule, kind of keep going, and we're going to do those experiments on those days as of now. Any other questions about anything? Okay, if there's not, then I'm going to officially end the lecture portion for today. It was good to see everybody virtually or talk to everybody virtually. And again, since we ran a little bit long, I'm going to wait about 10 minutes. So somewhere around 12:10, I'm going to open up the lab meeting. And again, if you need to get to that, you need to go back through Canvas and click on the one that's lab to get there. So we'll take a little break. We kind of ran a little bit long. So I'll open up about 12:10. And again, I'll be there probably until lab's normally over about 1:20ish. Again, if you need questions, you can hop in and stuff. So again, I would try to go work on that lab now just to get it out of the way. Other than that, everybody's good. I'll see some of you in a bit, I imagine. If not, I'll see the rest of you on Wednesday. And again, if you have questions, we'll open up that separate lab one. Other than that, go do your lab, I suppose. Yeah. I'll talk to everybody in a bit.